Hello, everybody. Welcome to another edition of the MakeCode Arcade Advanced stream. Sorry that we're a little bit late today because I was having computer troubles, but the computer troubles have been resolved. I am Richard on the MakeCode Forum.
I'm Joey at Wonder on the MakeCode Forum.
And I'm Thomas at Sparks on the MakeCode Forum.
And today we are continuing to work on our seagull game. So let's switch over to that. If you were with us last time, we were dealing with the problem that we wanted to have moving platforms in our game. And to do that, well, we've tried a few different strategies for this in the past, right? Where we had basically a extension that Joey and I did for a hackathon, where we replaced the entire physics engine with one that supported moving platforms. You can find links to that on the forum. I do not recommend that you use it because it's very buggy. But for some limited cases, it does work. Then in the past, we did a physics engine that was based off of the Celeste engine, which Maddie Thorson made a nice blog post about how the physics works in her games. And it was neat, but it meant that we couldn't use all of the rest of the arcade blocks because it was a completely separate paradigm. It was just a complete reimplementation, basically. So what we're doing today is we were looking at our arcade sprite tile maps extension, which is an extension we made on stream a while ago. That basically lets you set separate tile maps for each sprite on screen. And then we kind of determined that that was not the exact thing that we wanted. Because, you know, this is really a different scenario. What we want is, like, what we kind of came up with is what's in this post-it note here. So we want to do something that's like the background image scroller APIs, where we have layers of tile maps. All right. So all the tile map layers will get drawn from lowest to highest. We want to have some blocks for is overlapping with blank tile map, is overlapping or is colliding with blank tile map. And then we want all of the tile maps except for the bottom layer to allow out of bounds, right? So the bottom, right now, if you are out of bounds of a tile map, we consider that a wall. So we want these tile maps to treat you being outside as a not wall, just empty space. And only the bottom tile map will be the true tile map. And then we want to be able to set an XY offset for each layer. So this is where the moving stuff is going to come in. So you're going to be able to set the XY offset of each layer. And we're not going to do any sprite moving stuff. You're going to have to do that yourselves. But you should be able to use these is colliding with tile map and is overlapping with tile map blocks to make that happen.
And if you really want to do a sprite moving stuff, you could always do and move a sprite, but make it invisible and make this one just take its XY every frame.
Oh, wait, we're talking about two different things, but you're right. So we are not going to make these sprites also.
Yes.
Yes. Yeah. Okay. So with all that, I'm going to go ahead and copy this. We're going to start a new project, and we're going to be working on this extension today and see how far we can get. So let's go ahead and do a new thing. We're going to call this tile map layers create.
So you're going to use this to do moving platforms?
Yeah.
How's that going to work? Is it like each platform moves a tile at a time?
No. So we're going to have multiple tile map layers, right? And they're each going to have an XY offset, which does not necessarily have to be a tile offset.
Oh. Huh. I see. Okay, I guess that makes sense then.
Yeah. So the idea being that each of your platforms will be a different layer. And we are going to be able to set the X and Y each frame so that they move.
I see. So you're moving the entire map for that platform, basically.
Yes.
Yeah. Okay, it makes sense if the X and Y offsets don't have to be tied to tiles. Then.
Yeah, I don't think we need. I think we can do it. So we are going to have to figure out how to do that exactly, because the physics engine right now really assumes that everything is aligned to a grid. We do a lot of bit shifting in order to speed things up. I think we can make it happen, though, by just when we're doing collisions for an individual tile map, we create a fake little delegate guy who will be aligned to that origin, you know? So we'll do each of the tile map collisions with the sprite aligned to that origin, and then we'll kind of, you know, fix the position out for each one as we go on. Does that make sense?
Yeah.
Makes sense.
Okay. So we have a project here. We're going to be doing this in JavaScript, but to get started, we're going to create some tile maps that we can use for testing. So let's go ahead and do that. We're going to go ahead and do set tile map. I'm going to do 8x8 tile maps because I just like them better. So let's create an outer tile map. So I'm going to just make a classic brick tile like we always do. One of these days, maybe we'll just put a brick tile in the gallery. Wouldn't that be something? All right. And we'll go ahead and make a background tile like that. Go ahead and turn walls on. Put this in here. Great. Okay. Now we're going to make two more, and these are going to be platforms. All right. So let's go into tile util, grab out another tile map block, and we're going to go ahead and do platform 1 equals, and we're going to just make this a 3x1, and we're going to make a different color thing so that we can tell them apart. So we're just going to put in some random placeholder thingy. Like that. Up, up, up. There we go. All right. And we'll make another one. New variable. Platform 2. Oh, I forgot to mark walls. Walls. And we're going to make this one. Oh, whoops. Need to. I got a new one. There we go. We're going to make this one a little bit more interesting. So we'll make this one be 5x3. And I'm going to make it a different color just to make sure we don't get confused. And we'll make this one be like this. Just, I want something that you can be inside of, you know, while also still being a platform. So, all right, put that in there. There we go. Okay. So we have our two platforms. We have this as our outer tile map. Let's actually go ahead and put our outer tile map into a variable and get rid of this because we're not going to be using it. Outer tile map. All right. And now we're going to make a test sprite. So let's go ahead and create a duck. There we go. Move duck with buttons. And then I think we're good. I think that's all we want to do right now. So, all right. Switch over to JavaScript. I'm going to add custom.ts. And there we go. Okay. So first things first, we're going to go ahead and create a namespace for this. We're going to call this tile map layers. And we're going to export an enum. And this is going to be our layer enum. So this is going to be just like in the scroller thing. We need to have like, you know, layer 0, layer 1, layer layer 2, layer 3, layer 4, layer 5. Good enough. We're going to go ahead and give these all block annotations. So when you put a block annotation on an EDUB, this just controls what the string is that appears in the dropdown. So this one is going to be layer 0, and it's going to be background. And then paste, make this be just layer 1. Oops. All right. Make this 2, make this 3, make this 4, make this 5, and then we put top. All right. So the background one is the bottom. Stop. Maybe I should just put bottom. All right. Now we're going to go ahead and do export function. And we're going to say set tile map layer. And this is going to take in a tile map data, tiles.tilemap data. And it's going to take in a layer, which will actually make the first argument here. Okay. All right. Cool. And I'm going to go ahead and make a new file. We're going to call this api.ts. This is how I normally do things. And we're going to copy all this junk and put it into api.ts. So when I'm making extensions, I like to make an api.ts thing, and then everything that is a block, I put inside here. And then all of the extra actual implementation, I put in a different file. So makes it easy because when I want to just edit blocks, I don't want to have to scroll through all of my code, you know.
Makes sense.
All right. We're going to add an extension to this project, which is an extension you probably never want to use, but I like it, which is, oh, shoot, what did I call this extension? Arcade extension utils. Yes.
Nice.
And this just has like one function in it, which is, I'm going to want to create a class here, which is going to be called state. And we're going to do export function state, which is going to return type state. And then we're going to make a function, which is called state factory. I'm sorry, this is all just going to be a bunch of gobbledygook. This is just the stuff that I do for every new extension. And this is going to be return __ util dot get state factory. There we go. And now I'm going to store all of the state for my extension inside of this class. And everywhere that I need to reference it, I'm going to call this state function. The reason I put an underscore at the beginning is because this gets filtered out of the autocomplete. Like if I start typing or state or something, you'll see that it does not show up in this list. That's because we filter out everything that starts with an underscore. But the reason I'm using this util get state function is because Arcade has this concept of things called scenes. There is like a base scene, which is your game. If you pause, that creates a new scene on top. This util get state makes it so that you create a new state for every scene in the game. So that's it. All right. Now with that, we're going to go ahead and do layers inside of the state, which is going to be a tiles.tilemapData array. We're going to go ahead and do a constructor. And we're going to say this dot layers equals empty array. All right. And now we're going to go ahead and do set layer. And this is going to take in a layer array value. Whoops. And a map. And then we're going to say this dot layers of layer equals map. Great. Okay, we did it. So let's go ahead and call this over in our API. So over here, we're going to do state dot set layer layer map. Tile map. Whatever. Cool. All right. So let's come up with a game plan here. What are we going to have to do to make this work? So the important things we have here are, one, we need to have a physics engine that takes all tile maps into account when moving sprites, right? So we definitely need that. Two, we need an implementation of the tile map class. So the tile map, I think it's actually capital M. The tile map class is different than the tile map data. If you look at the scene object by doing game.currentScene, there is a tile map on here. It's a singleton that gets created for each scene. And this is what it handles. This is what the physics engine looks at. But this is also what handles drawing the tile map. And that's the main thing that we're interested in. Because right now, the tile map class very much assumes that it's always drawing from the same origin. We're going to have tile map layers that have offsets. And so we need to make our own class. So tile map class that can draw at different points like that. And now finally, we're going to need a layer class which stores layer state, right? So right now we're just storing this array of tiles.tilemap data. We also need to store like the offset and things like that. So this one's going to be the easiest to do. So let's just start that. We're going to do class tile map layer. This is going to be a constructor. This is going to have an X, which will be a number, a Y, which is a number, and then a map, which is a tiles.tilemap data, like that. And we're going to go ahead and take this thing that we just did. We're going to replace it with tile map layer. And now what we're going to do is say, if there is already a layer, we just want to swap out the map here. So we're going to say, if this dot layers of layer, let's do let layer impl equal, be a tile map layer like that. Then we're going to say layer impl equals this dot layers. You know, we could just do this, move this down a line, and then say this dot layers of layer equals new tile map layer, like that. In fact, we don't even need this variable. What am I doing? All right. There we go. All right. So that works. Next up, I guess we should initialize this. So we'll go ahead and do this dot x equals 0, this dot y equals 0. Let's go ahead and do set layer offset. So this is going to take in a layer. This is going to take in an x and a y. And we're going to go ahead and say const layer, const tile map layer equals this dot layers layer. Now, if this doesn't exist, I guess maybe what we want to do is a get layer function, which takes in a layer and then has a create if missing. And then we're going to do, oh, I also inverted this. All right. If not this dot layers dot layer and create if missing, then we're going to go ahead and create this. And then we can go ahead and return this like that. And then right here, we're going to go ahead and just change this to this.getLayer, layer true, like that. And then right here, we're going to say, again, layer true. And we're going to go ahead and say tile map layer dot x equals x. Tile map layer dot y equals y. All right. Let's go over to api.ts. Oh, well, go back. Copy this function. Over here. Export function. That right there. And then we're going to go ahead and just do state dot set layer offset. And then pass in layer x, y. All right, cool. Okay. Let's call these functions so that as we start implementing stuff will actually show up. So we're going to go back over to main.ts. And we're going to go ahead and say tile map layers dot set tile map layer layers dot layer 0 to be outer tile map. All right, and we're going to set layer 1 to be platform 1. And we're going to set layer 2 to be platform 2. And then we're going to set the offsets for layer 1 and layer 2. So do tile map layers dot set layer offset tile map layers dot layer 1, and then we'll set this one to be, I don't know, any arbitrary number. Like we'll put it in the center of the screen. So 80, 60. Oh, whoops. There we go. And then for the other one, just somewhere else. We'll just do 4,100. There we go. All right. And make this 2. All right. Okay. So this is going to do nothing right now. I mean, it's going to call that code we wrote, but we don't have it hooked up to actually like drawing anything or anything like that. Mm-hmm. So that's going to be good enough for now. What we're going to do now is we're going to go ahead and look at the tile map class because we're going to be extending that in just a second. So we're going to go to game. We're going to go down to tilemap.ts right here. And now in here somewhere is a tile map class. Tile map data, not what we want. Tile map event, tile. All right. So in here, we have a get scale, set scale. We have an offset X, offset Y. So this returns, I think this just clamps. Mm-hmm. Yeah. Area width, area height, makes sense. Get layer, set layer. We don't have to worry about this. Set data, so this is what actually sets the data. Then we have get tile index, set tile at, get image type, set wall at, get tiles by type, sample tiles by type. I actually don't know what that is. Is invalid index, draw is obstacle, get obstacle is on wall, get tile image, Okay, so I don't think there's actually that much we have to do here because we're not going to be calling a lot of these functions. So let's get to it. Let's just override draw for now. So we're going to go back to custom.ts and we're going to go ahead and do class and we're going to call this just tile map. And we're going to extend tiles dot tile map, and I forgot the S. There we go. And we're going to take a draw, and we're going to override that. All right. I need to know what the parameters are for this. Tell me the parameters.
X, Y. Is it
What if I
easier
do
to copy the
super
whole?
dot draw?
Yeah.
All right. Target, image, and camera. Okay. There we go. All right. And what we're going to do is we're going to go ahead and make a constructor for this. And this is going to take in a layer. And that we're going to store on the class. And we're going to go ahead and call super, and we're going to pass in. Why does tile map take in a scale? It should just get it from the map. Whatever. We're just not going to pass it in. All right. Why are you unhappy? Oh, right. There's already a layer thing. We'll go ahead and call this tile map layer. By the way, the layer thing is a thing that exists for the tile map and for sprites, but we never actually use it anywhere. Yeah. This is something that has existed since the beginning of Arcade. It was an idea that got checked in, where basically the idea is you can have different layers of sprites and tile maps, right? But then we implemented all of this other stuff on top of it, but did not take layer into account. So don't use layer is the thing that I'm trying to tell you now. It will probably not work right, but that was the idea. So we'll call this tile map layer. All right. And we need to go ahead and override this draw. So let's actually just copy the draw and we'll edit it. So head back to tile map. Let's see. All right. Just copy all this junk. Head back over. Paste it in there. All right. Let's look through this code. Okay. Let's see. We have this game.debug stuff. Don't care. Go away. So what this code basically does is it figures out, okay, what is the leftmost tile that is on screen? What is the rightmost tile that's on screen? What is the topmost? What is the bottommost? And then it loops over those and then draws them to the screen. Simple enough. So what we're going to be doing is we have this offset X, offset Y, which right now we're just setting to be the camera draw offset X and camera draw offset Y, and this bit mask. This bit mask is just to align it to the grid. Wait, what? What is this doing?
That is making it so that it does the one to the left as well, right? Or am I wrong? Like because it has to do like one extra and one on the left potentially.
That's what this is doing.
That is what that is doing. Never mind then.
Oh, this is getting the... Nope, still don't get it. Oh, this is getting the remainder. I don't know why it's doing it this way instead of doing a modulo. I guess just to be fancy.
Gotcha.
Or more fun this way?
Yeah. All right. Well, anyway. Okay, so what we're going to do is we're just going to be adjusting this camera draw offset X by whatever our layer X and Y is. Okay. So we're going to go ahead and do, let's see, let's do const camera offset x equals camera dot draw offset x minus this dot tile map layer dot x. And we're going to go into everywhere that we're using camera draw offset x, and we're just going to replace it with this. Same thing for y. And I think that should do it. I don't know. Let's just hook it up and see if it works. All right. So we're going to go ahead and inside of this tile map layer constructor, let's go ahead and just do a drawer. Okay. And this should just do nothing. I think we have to do this dot enabled equals true. What?
This dot set enabled true or something?
This dot. Oh, we need to do. I think enabled is just seeing if it has data or not.
Oh, okay.
So we're gonna go say if not this dot enabled, and then say if this dot tile map layer dot map this dot set data this dot tile map layer dot map else return.
Hey,
there we go. Okay. All right. Our map is drawing, not correctly, but it's drawing. So, okay, we're going to have to actually think about this now. All right, so right here, when we're doing it, this is obviously not working, right? Oh, should this actually be plus? I don't think that's gonna fix it, but okay, nope, apparently not. Or wait, it should be this minus.
Gotcha.
Nope. Okay. I'm gonna get rid of this weird bitmask stuff because I don't really get it. So we're going to figure out what our I don't know why I'm every time I'm on stream, my brain just blanks. Okay, we're gonna draw this out. There you go.
Yeah, I think you got some errors there with the offset X, offset Y.
Yeah, because I deleted them.
Yeah. Okay. All right. This is our screen. This is our tile map.
Mm-hmm.
This is our X. This is our Y, right? So for here, we have X equals whatever. And by actually, I mean, this is the camera, not that this is the screen. This is the camera, right? So we need to figure out which tiles are visible, right? So we need to first adjust our tile map such that it's aligned properly with this camera, right? So we need to figure out what the difference between the top left of the camera is and the top left of our tile map, the XY, right? Once we do that, the leftmost tile is going to be just whatever this is. We'll be, once we have that, we'll figure out what this, we'll know how many tiles are cut off on the left, right? Because it'll be equal to the floor of this divided by the tile width. So that'll give us the x0. And then we can, yeah, okay. I think I got this. I think I got it. Let's put this aside. Okay.
Yeah. Looking at this one other question.
Yeah.
Do we want to consider a case where we want the main tile map to have 16 by 16 tiles and the sub tile maps to have 4 by 4 tiles?
Boo.
Okay.
Get out of
here. That's what I thought the
here.
answer was going to be. I was just asking ahead of time.
Maybe once we get everything working, we can think about that. For now, absolutely not. Okay. So to figure out x0, we're going to go ahead and do this dot tile map layer dot x minus camera dot draw offset x. And then we're going to take this, shift it by this dot scale. Okay, so if our x is -20 and our camera draw offset x is 0, then we want, this is going to give us a negative number. So we're going to go ahead and, actually, is this just coming back to what we had before? Yeah, it is. Okay. So that's right. Then here, we are doing camera offset x plus target dot width. So this will actually be returning an x in. Okay, right. And then we do a minimum with this dot map dot width. Okay, that actually seems right. I think perhaps the only thing that we have a problem here is this part, right?
Mm-hmm.
So I think we are getting the proper bounds for x0, xin, y0, yn. But if we want to double check that, we can actually, let's just comment this out for now so that it builds again. And we can go ahead and do console.log. And we're going to go ahead and just log width, this dot map dot width. Oh, underscore map, of course. Whoops. Great. All right. Do that. Go down here. Stop. Okay. So for our outer map, the width 20, height 15, we're going from 0 to 20 and 0 to 15. That's correct. Mm-hmm. For our width 5, height 3, 1, we are going from 5 to 5 and 12 to 3. Okay, that's wrong.
That's very not right.
Yes, this is very incorrect. And then for our 3, 1, 1, we're going from 10 to 3. These should both read 3 to 1, 0 to 3, 0 to 1, 0 to 5, 0 to 3. Because they should be fully on screen right now. All right. So our math is definitely wrong here. So we're doing a max of camera.offset x shifted by this dot scale. I think what we're going to do instead is do.
So I guess this is where it's.
We didn't pass
rendering,
any.
but it's not going to correspond to the.
What'd you say, Thomas?
Oh, well, I was just wondering if we're getting messed up because we didn't pass in a scale. I don't know what the default is. Just doing something weird.
It gets set when you set the tile map.
Okay.
Yeah.
So that should just be a no-op.
It'll be for an 8x8 tile. It'll be this will be equal to 3 because shifting left 3 is multiplying by 8. Shifting right 3 is dividing by 8.
Gotcha.
Yeah.
Oh, that's what they means by scale. I see.
Yep.
I was thinking like zoom in, zoom out scale.
No, we only use this for the shifting. Woof Woof says, I was wondering what layer was for. Yep. Oh, you're way behind us, Woof Woof. Nah, they'll see it in a few minutes.
Yeah. So what can we do?
All right. So, okay. So right now, our camera draw offset x is equal to 0. Our tile map layer.x is equal to like 40. Okay. So this is doing 40 right shifted by this dot scale. That's definitely wrong. Okay.
Yes, not right. That's not what the number we're looking for means.
That's not exactly. So what we actually want to do is figure out if the camera is over, going back to our image over here. I'm going to delete this actually. Okay, so with this being our camera and this being our tile map, we want to see at what, oh, this is not actually a helpful case. Okay, do this one, do this one. Okay, we want to figure out at what x does the camera left appear relative to the origin of our thing. So we actually want to do the opposite. We want to do the camera left minus our x.
Yeah. Well, yeah. We had that at first, but then it felt wrong. But yes, that was correct first thought.
Woof says, yeah, I am behind. Yes, you did just say that a few seconds ago for me. Okay. So yeah, we did say that like 5 minutes ago. All right. So we're going to go ahead and do this.
I'm catching up using 1.5 speed on the YouTube stream. Okay. Are you watching it twice then? Like the current stream and then the... Okay.
All right. So we want to, when we're drawing this transparent image, right? This gives us the offset from the tile map. And we want to draw this from our... So we're going to do plus this dot tile map layer dot x minus camera dot draw offset x for the drawing part.
I started at the beginning of the stream. Yeah, I mean, that makes sense. Yeah.
All right. Okay. We did it. All right. This is now correct. Okay. That took way longer than it should have. All right, so we now have all of our tile map layers being drawn. This is the center of the screen for the top left of this one. This one was at 40, which this looks about 40, and then 100Y, and that looks about right for that too. So, all right, we're good. We got it. Okay. Get rid of this console log. All right, so now that we have it actually drawing, we need to do the physics engine. So to do that, we're going to create a new file because this is going to be a big file. And we're going to go ahead and do namespace tile map layers. And we're going to just copy the entire physics engine. So we're going to go to game. We're going to go to physics. Go down here to arcade physics engine. Collapse, copy, physics, paste. Export. Great. All right. So a lot of this stuff we don't actually have to change. So maybe we can get away with extending this.
We probably only have to move the tile map. Isn't there a separate tile map collisions?
We need anything that has tile maps we need to override. So let's just go ahead and do, all right, we're going to call this just physics engine. And let's go ahead and do extends arcade physics engine. We're going to go ahead and call super with these parameters, delete all of this, and we're just going to delete stuff that we don't need to override. So all of this can go. This mentions tile maps. We're going to have to fix that. Get rid of this. Don't need that. Okay, move. Definitely need to overwrite that. Create moving sprite. Does this mention tile maps? No. Okay, we can go ahead and toss this one. Sprite collisions. So this is collisions with other sprites, but let's make sure that it doesn't mention anything to do with tile maps in here. Yeah, looking good. Okay, I don't think we need to do anything with this. Screen edge collisions. We don't have to do anything with that. Tile map collisions. I wonder. Yeah, we're gonna have to do something with that, obviously. Tile map overlaps, that too. You can go ahead and get rid of this. Move sprite. Yep, we're gonna have to do something with this one. Can resolve clipping. We're gonna have to do something with this. And then constrain. Don't need to do anything with that. Okay, cool. All right. So what are we going to be doing here? Well, our basic strategy is going to be we need to make it so that when we do our tile map collisions, we are going to do the tile map collisions for each of our tile maps, one after the other. All right. So we're going to start with the lowest layer, and we're just going to work our way up. And let's see. This is going to get complicated because let's see where we do our actual collisions checks. So go to tile map collisions. Joey is most familiar with this code because fun history of this. Mihao wrote this originally, then I rewrote it, and then Joey rewrote my code. So Joey's the most.
I think there's another rewrite, and then I rewrote it again after that, but I don't remember.
I don't know. It's Joey and I have both rewritten this multiple times, I think is the lesson here. All right. So the way this works is we figure out the difference between our x and our last x and our y and our last y. And then we, let's see.
First we do the x.
So we move by one tile at a time, right? And every time we move forward by one tile, we check, did we do any collisions? If we did, then we bump ourselves back to where we were, right? So by doing one tile at a time, that makes sure that we don't skip any tiles, right? Because we can never move fully over a tile by moving one tile at a time. Now, this is trickier with this because moving one tile at a time. Well, no, that should still be safe, shouldn't it?
I think was it moving one tile at a time or checking one tile at a time? Because it moves in smaller increments than that even, because it checks like sprite overlaps in turn.
We're adding tile size to.
Gotcha. Yeah.
Well, now you got me wondering. Okay, so we set y equal to the difference between the top of our hitbox and the amount that we're moving in the y direction.
Yeah. So the comment up there is check tiles with collisions with tiles. Sprite is moving towards horizontally. So this is after.
Right. So this is after we've moved.
This is just checking like these three like tiles are ones that you are currently touching when you're moving in this direction.
Exactly. So this is not doing the actual moving. This is we have already moved. Did we collide? If we did collide, bounce us back.
Yeah. The actual movement is called prior to this, and then this is just doing it after the fact to clean up, basically.
The actual moving is right here.
Yes.
So here we add our SXSY. Then we do the tile map collisions. And then, okay, so I think we might not have to do too much. So with this function, we're going to have to loop over all of our tile maps and call tile map collisions, right? And inside of tile map collisions, we're going to have to edit this to also take into account the offset X, offset Y, right? But I think those two things will be enough to get the basic idea working.
That sounds right. Yes.
Cool.
Yeah. The only thing that's going to be tricky is imagine you have two tile maps overlapping right here. And when you move, you are now colliding with both of them. Then on the same check, on the same move step, right? Then we would have to, if we do a tile map collision, we would then have to adjust our XY. Oh, no, that'll work. That'll work. Because the tile map collisions already adjust our XY to the appropriate amount. So we can just keep calling tile map collisions, and it might adjust it more, but that'll be totally okay.
Yeah. I'm sure there'll be a way that it will get stuck, and at that point, it is just where we have to call, it's clipping behavior, like we had said. Like we'll have a event for it.
Yeah. And then tile map overlaps, we're not going to worry about that right now. Move sprite. Right. This also calls tile map collision, so we'll have to do this one too. And then can resolve clipping. I don't know what this does. We could figure that out later. All right. Cool. All right. We could do this. This is going to take us a few more streams for sure, but I think we can get the basic thing working next stream. So, but next stream is actually going to be our mini game jam stream. So if you haven't made a game for the mini game jam yet, there's still time. You can find more details about it on the forum, but this Friday, we're going to be playing all of your mini game jam games. So please submit a game. It's construction themed. We'll have a lot of fun. Mm-hmm. And then next week on Wednesday, we are not going to have stream. So I'll post about that on the forum, but just FYI, we're all going to be at an event. So, we won't be able to have stream that day. Mm-hmm. But all right. And that's it. I am Richard at Richard on the MakeCode forum.
I'm Joe at J1 on the MakeCode forum.
I'm Thomas at Sparks on the MakeCode forum.
And we'll see you on Friday. Bye.
Bye.